Hello friends. I am Satish Lele. This video is part of my chemical process typing channel on YouTube. This video is about plant layout. Some definitions of boundary. Guide. Division wall. Fire resistive. High flash stock. Low flash stocks. Non-combustible. Pipe rack. Plot plan. Sleepers. Tank diameter. Tank spacing. Toe wall. Vessel diameter. And vessel spacing. Boundary of the equipment is the term used in a processing facility by an imaginary line that completely encompasses the defined site. Dike is an earth or concrete wall providing a specified liquid retention capacity. Division wall. It is an earth or concrete wall which directs spills to a safe disposal area. Fire resistive. Fire resistance rating. As the time in minutes or hours, the materials or assemblies have withstand the fire exposure as established in accordance with the test of NFPA 251. High flash stock. Those having a closed cut flash point of 55 degrees centigrade or over, such as heavy fuel oil, lubricating oils, transformer oils, etc. This category does not include any stock that may be stored at temperatures above or within 8 degrees centigrade of its flash point. Low flash stocks are those having a closed cut flash point under 55 degrees centigrade, such as gasoline, kerosene, jet fuels, some heating oils, diesel fuels, and any other stock that may be stored at temperatures above or within 8 degrees centigrade of its flash point. Non-combustible material incapable of igniting or supporting combustion. Pipe rack. The pipe rack is the elevated supporting structure used to convey piping between equipment. This structure is also utilized for cable trays associated with electric power distribution and for instrument tree. Plot plan. The plot plan is the scale plan drawing of the processing facility. Sleepers. The sleepers comprise the grade level supporting structure for piping between equipment for facilities. For example, tank, farm, or other remote areas. Tank diameter. Rear tank spacing is expressed in terms of tank diameter. The following criteria governs. If tanks are in different services, or different types of tanks are used, the diameter of the tank which requires the greater spacing is used. If tanks are in similar services, the diameter of the largest tank is used. Tank spacing. It is the unobstructed distance between tank shelves, or between tank shelves and the nearest edge of adjacent equipment, property lines, or buildings. Toe wall. It is a low earth, concrete, or masonry unit curb without capacity requirements for the retention of small leaks or spills. Vessel diameter. Where vessel spacing is expressed in terms of vessel diameter, the diameter of the largest vessel is used. For steroids, the diameter at the maximum equator is used. Vessel spacing. It is the unobstructed distance between vessel shelves or between vessel shelves and nearest edge of adjacent equipment, property lines, or buildings. Some key issues related to layout are terrain, safety and environment, plant piping location, basic considerations, division in blocks, location, weather, prevailing wind, layout indication. Terrain. In the first place, considerations should be given to the physical setting. It should not automatically be assumed that it is necessary to level the site. There may instead be ways that the process can take the advantage of whatever slopes are present. With respect to terrain, assess should be made whether there is adequate space in general. If not, ingenuity will be required to meet such requirements as those for flares. Available space can help to govern whether the plant can be located on one floor or instead occupy several stories. The physical setting shall also be considered in light of the transportation requirements for raw materials, products, wastes and supplies. Safety and environment are familiarization with pertinent environmental regulations, local as well as national and international, and how they might change is essential. Period. To conclusion of pre-project studies, attention shall be given to the pertinent safety regulations, including health and welfare needs. Hazardous and flammable materials require special handling, which can take up layout space. If the process fluids are especially toxic, layout is affected by the need for close chemical sewers and other protection measures. Security requirements may require special layout design when the plant produces a high-value product. If the plant site is governed by particular building, piping, plumbing, electrical and other codes, these can affect plant layout. Similar governing standards and regulation in plant site affects the layout concept. Plant capacity. It is important not only to know the initial capacity but also to have a good feel for how much a plant might be expanded in the future, as well as how likely the process technology is to be modernized. These factors indicate how much space should be left for additional equipment. Multiple processing lines are often required for the plant. Pairs of lines can either be identical or be mirror images. The former option is less expensive, but the mirror image approach is sometimes preferable for layout reasons. Two such reasons are: for operator access via central aisle, the need that the outlet sides of two lines of equipment pumps, for instance, point toward each other so that they can be readily hooked to one common line. Basic considerations for the plant layout shall be arranged to maximize safety, prevent spread of fire, facilitate easy operation and maintenance, consider future expansion, economize project. Blocking. The plant site shall be blocked in consideration of hazards attendant to plant operation in the area. All blocked areas shall be formed as square as possible by divided access roads and slash or boundary lines. Location and weather. The plant layout shall be arranged in consideration of geographic location and weather in the region of the site where the prevailing line is defined. The administration and service facilities and directly fired equipment, etc., shall not be located when the rate of process units and storage tanks, etc. Layout indication. The basic requirements to be met in the appropriate diagram when making the piping and equipment layout are: all equipment, ladders, structures, davits, trolley beams, shall be indicated. All instruments shall be located and indicated. All valving and handwheel orientations shall be indicated. Drip funnel locations for underground drains shall be indicated. All electrical switch gear, lighting panels shall be indicated. All sample systems shall be indicated. Classification of hazards. The plant layout shall be determined in consideration of classified hazardous areas. Plant site is governed by particular design codes. Building, piping, plumbing, electrical, other codes. Plant layout or area arrangement is classified as blocked areas, such as process areas, storage areas, utilities areas, administration and service areas, and other areas shall be decided on the basis of following factors: soil characteristics, main road, rail access ways, and jetty, location of pipeline to and from plant, direction of prevailing wind, local law and regulation which may affect the location of units and storage facilities. Natural elevation for location of upstream or downstream units and equipment such as feed and product storage tanks, wastewater plant, oil and water separator, etc. The process area shall be located in the most convenient place for operating the process unit. The units shall be separated by roads. Major roads shall have minimum width of 10 meters, with maximum length of 400 meters. The minor roads shall have minimum width of 6 meters. Minor roads shall not be in an area classified as Zone 0 or 1. The plant may contain one or several process units. Where any unit processes flammable fluids and may be operated independently, i.e. one unit may be shut down with others in operation. The minimum spacing between equipment on the two adjacent units shall be at least 20 meters. The storage area shall be located as far as possible from buildings occupied by personnel at the site, but should be located near the process area for ready operation of the feedstocks and product rundowns. The utilities area shall be located beside the process area for ready supply of utilities, except where they are an integral part of a process unit. Site utility units should be grouped together in an area classified as non-hazardous. Loading and unloading area shall be located on a corner of the site with capable connection to public road directly for inland traffics. Loading/unloading areas for road transport shall have adequate space to provide access for filling, parking and maneuvering. The drive-through rack arrangement is preferred. The loading and unloading facilities should be downwind or crosswind from process units and sources of ignition, based on the direction of prevailing wind. For marine transportation, the area shall be located on the seaside or riverside in the plant site. The administration and service area shall be located at a safe place on the site in order to protect personnel from hazards. It shall preferably be located near the main gate alongside the main road of the plant. Flare and burn pit shall be located at the end of the site with sufficient distance to prevent personnel hazard. Wastewater treating unit shall be located near at the lowest point of the site so as to collect all of effluent streams from the processing unit. The process unit to which the feedstock is charged first shall be located on the side near the feedstock tanks to minimize the length of the feed line. The process unit from which the final products are withdrawn shall be located on the side near the products tanks to minimize the length of the product rundown line. Process units, in which large quantities of utilities are consumed, should be preferably located on the side near the utility center. Security fence. All sides planned for complex shall be within security fence. The minimum space between security fence and units boundary shall be 20 meters, and between security fence and equipment shall be 30 meters. In case of special units such as flammable material storage with vapor release and toxic materials, minimum space shall be at least 60 meters from site boundaries adjacent to centers of population, domestic, work or leisure. Fire water pumps and equipment shall be sufficiently remote from processing, storage and loading areas where a major fire could occur. Road and access ways shall offer easy access for mobile equipment during construction and maintenance, firefighting and emergency escape in a fire situation. Access roads shall be at least 3 meters from processing equipment between road edges to prevent vehicle collisions. Pipe racks and sleepers. In general, pipe racks for process units and pipe sleepers for the off-site facilities shall be considered as the principal support of the pipeway. Run pipe lines overhead should be grouped in pipe racks in a systematic manner. Pipe rack runs oriented in the same direction shall be at consistent elevations. Pipe rack runs oriented opposite to these runs shall be at other elevations to accommodate crossing of lines at pipe racks junctions and to accommodate branch line intersections. Single-level pipe racks are preferred, if more than one level is required. The distance between 1.25 meters. Maximum pipe rack width shall be 10 meters. If widths larger than 10 meters are required, the pipe rack shall be designed to be of 2 stages. Actual width shall be 110% of the required width for the required width plus 1 m. In cases where air-fin coolers are to be placed on the pipe racks, the pipe rack width shall be adjusted based on the length of the air coolers. Avoid flash turns. When changing directions, change elevation. Allow ample space for routing instrument lines and electrical conduit. Provide 25% additional space for future instrument lines and electrical conduit adjacent to that required. Provide 20% additional space on the pipe rack for future piping. This space shall be continued and clear on each level for the full length of the rack. The width allocation may be split into sections at not more than 2. Allow continuous clear area of 4 meters high by 4 meters wide below main racks in process units for maintenance access ways. Pipe racks outside process areas shall have the following minimum overhead refinery or plant clearances: main roadway, 5 meters, access roads, 4.5 meters, railroads, 6.7 meters above top of rail. Typical layout of pipe rack for process plants depending on the number of process units incorporated and the process complexities are given in figures with reference descriptions as follows. Single rack type layout is suitable for small-scale process complex consisting of 2 or 3 process units. It is economical without requiring any large area. Cone type layout is recommended for use in process complex consisting of 3 or more process units. Single rack type in this case will not be suitable since separate maintenance and utility administration in normal operation will be difficult because of the utility and flare lines which are placed on the common rack. Double cone type layout is an expansion of the cone type which is recommended for the use in large-scale process complexes where 5 to 10 process units are to be arranged. This layout can be conveniently utilized. U-type layout is recommended to be used in case of process units whose maintenance cannot be conducted separately within the complex. This type can be regarded as an expansion of the single rack type. Even process complexes of this nature can be regarded as one process unit in the planning of the layout. Overhead racks may contain more than one level. For steel pipe racks, the height of levels shall have one of the following elevations. Main pipe racks 4.60, 6.20, 7.80 meters. Individual or secondary pipe rack 3.80, 5.40, 7.00 meters. In special cases for large-size pipes or concrete pipe racks, the distance between the various floors may be increased. Except for special cases, minimum width of pipe rack shall be 6 meters. The width of pipe rack shall be designed to accommodate all pipes involved plus 20% space for future expansion or modification. Where the pipe rack supports air coolers, the preferred width shall be the width of air coolers. In multi-level pipe racks, pipe carrying corrosive fluids shall be on the lower level, and utility lines should be at the upper floor. Large size or heavyweight pipes shall be located at the lower level and on extreme side. Layout of control room and electrical substation. The control room and substation shall be located as close as possible to the plant equipment, maintaining a minimum distance from viewpoint of noise and safety requirements. The control rooms and substation shall be spaced at least 15 meters from the nearest process equipment surface. The control room and substation shall be located with consideration to convenient and daily operation. The control room and substation shall be located from an economical standpoint so as to minimize the length of electrical and instrument cables entering and leaving, therefore. The control room shall be positioned so that the operator can command a view of the whole system which is under control. Large buildings or equipment shall not be placed in front of the control room. Location of electrical substation. The electrical substation shall be located with consideration to convenience in daily operation. The electrical substation shall be located from an economical standpoint so as to minimize length of electrical and instrument cables entering and leaving. Firefighting requirements. Each individual process unit shall be provided with sufficient open spaces there around that fire trucks can be run and operated thereat. The width of access way thereto shall be 6 meters minimum. Process units consisting of large hazardous material storage tanks should be located desirably in outer area in the complex site. High-pressure gas lines shall not pass through a process area or run within 30 meters of important structures or equipment without shutdown valves to ensure that portions of piping within the process area can be isolated from the main gas line and depressurized in the event of an emergency. However, extensive use of shutdown valves may not be needed, since the increased complexity of the system will require a greater degree of preventive maintenance if unwarranted shutdowns are to be avoided. Shut-off valves, sometimes known as station isolation valves, shall be provided on all gas and product pipelines into and out of the plant. The bypass line with a normally shut valve may be required between plant inlet and discharge lines. All station isolation valves and bypass valves, if any, should be located at a minimum distance of 75 meters but not more than 150 meters from any part of the planned operations. Care should be taken in locating these valves so that they will not be exposed to damage by plant equipment or vehicular traffic. At least 2 remote emergency shutdown stations, located at a minimum distance of 75 meters apart, shall be provided. Locate actuating points at least 30 meters from compressor buildings and high-pressure gas lines. More than 2 shutdown stations may be required, depending on the size and complexity of a given plant. One of the actuating stations shall be located in the control room. It shall be distinctively marked and equipped with signs stating the proper method of actuation in the event of an emergency. Wastewater separators handling hydrocarbons should be spaced at least 30 meters from process unit equipment handling flammable liquids and 60 meters from heaters or other continuous sources of ignition. Preferably, wastewater separators should be located downgrade of process equipment and tanks. Fire training areas are ignition sources when in use. Because of the smoke produced, they can also create a nuisance for the refinery and neighboring facilities. Fire training areas shall be 60 meters from process unit battery limits, main control rooms, fired steam generators, fire pumps, coolant towers, and all types of storage tanks. They shall also be 75 meters from property boundaries, administration, shops, and similar buildings and from the main substation. Building requirements. Service buildings include offices, control rooms, laboratories, houses, shops, warehouses, garages, cafeterias, and hospitals. These structures and areas require protection of personnel from possible fires and explosions of major plant equipment and may require additional spacing from high-risk facilities. The service buildings shall be located near the entrance of the plant and be readily accessible to a public road or highway. Spacing at refineries, petrochemicals, chemicals, and gas plants or buildings shall be in accordance with insurance recommendation. Access requirements. Access ways within the plant shall be provided for maintenance, emergency case, and for firefighting from the road around the plant. Piping system shall be laid in such a way to make possible passage of mobile equipment. Operating passageway between equipment or piping and adjacent equipment generally is 10-15 mm minimum except when otherwise shown on drawings, Minimum widths of access ways shall be as follows. Vehicular access ways within units, 4.0 meters. Pedestrian access ways and elevated walkway, 1.2 meters. Stairways and platforms, 0.8 meter. Footpaths in tanks areas, 0.6 meter. Maintenance access around equipment, 1 meter. Fire truck access way, 6 meters. Minimum headroom clearance for access ways shall be as follows. Over railways or main road, 6.8 meters. Over access road for heavy trucks, 6 meters. For passage of truck, 4 meters. For passage of personnel, 2.1 meters. Over forklift truck access, 2.7 meters. Thanks for learning. If you like this video, please give a like to my channel and subscribe it.